Welcome to DSIN machineries. Building furniture with compound angles typically demands significant experiences and precise craftsmanship, and maybe a few deep breaths. But don't worry, in this project, we'll show you how our universal router makes the job much simpler. Plus, we'll walk you through some of its advanced features that take the stress out of the complex build. First, we need to determine the angle of the stool legs. In this design, each leg is inclined at 80 degrees in both directions. As you can see here, we're also using different types of joinery methods. For example, the top of each leg uses a round tenon. We'll use a 10mm straight spiral bit with a round tenon template to create a 24mm diameter round tenon. For the round mortise, we'll simply use a 24mm Forstner bit to drill matching holes on the benchtop. For the side supports and middle supports, we'll use the same spiral bit but pair it with a track-style oval template to create oval tenons on each side of the support, and then use the slot on the same template to cut the matching oval mortise. The first step is to make a mortise on each leg. We'll draw a center line at the desired position. Use the laser to align it precisely, and set up a stop block to ensure all the mortise are in the same position. After securing the wood, we can move on to locating the exact position for each mortise. To find the center position of the mortise, lower the drill bit until it gently touches the top of the workpiece. Then, record the number shown on the position indicator. Since each leg is 43mm thick, a quick calculation will help you set the drill bit exactly at the center of the leg. The position indicator reads 14.5. We need to account for the radius for the drill bit, which is 5mm, and add half of the thickness of the workpiece, which is 21.5mm. Add them together and we get a total of 41. Move the position indicators to 41 and double check to make sure the center of the drill bit is aligned with the center of the mortise position. Next, set the mortise depth to 20mm. Then, insert the position pin into the slot on the template. The pin will move within the slot to create the mortise shape we want. Let's start making the mortises and repeat the same process for all 4 legs. Before we start making the compound angles on the 4 legs, let's go over a few basic concepts to help us set up the universal router properly. The first concept is that leg 1 and leg 3 belongs to one group, while leg 2 and leg 4 belongs to another. If we move leg 3 aside, you can see the mortise here. It connects with leg 2. And if we move leg 1 into the same position, it serves the same function as leg 3. That means leg 1 and leg 3 share the same setup on the universal router. The second concept is that when we're cutting the top of leg 2, it actually shares the same setting as the bottom of leg 1, also known as bottom 1. And since bottom 1 is the same as bottom 3, that means bottom 1, bottom 3, top 2, and top 4 all share the same setting on the universal router. Okay, time to start making the compound angle. First, tilt the work surface to 10 degrees. Next, loosen the stop block at the back of the universal router. This stop block normally keeps the workstation straight at 0 degrees, but for this project, we'll rotate the workstation 10 degrees to the right. Once that's done, lock it in place so that we can make consistent, repeatable cuts. Move the machine so that the router bit gently touches the upper right corner of the workpiece. As you can see, by tilting the work surface upward by 10 degrees, we can cut a 10 degrees angle from the top to the bottom. And by rotating the workstation 10 degrees to the right, we can cut another 10 degrees from right to left. Together, these two angles formed the compound angle for the leg. Set the depth gauge to 0, and we can start cutting the compound angles. Remember when we mentioned that one machine setting allows us to cut all 4 leg surfaces? Here's how it works. Top 1 and the top 3 belongs to one group, while top 2 and top 4 belongs to another. We've already cut top 1 and top 3, and this same setting also applies to bottom 2 and bottom 4. But you'll notice that bottom 2 and bottom 4 don't look the same as top 1 and top 3. That's because you need to flip bottom 2 and bottom 4 180 degrees so that they match the same cutting orientation. Here's how it actually works. Top 1 is the same as bottom 2, but you need to flip bottom 2 180 degrees so that it matches the same cutting orientation. Now we can cut bottom 2 and bottom 4 at the same setting. Now, without changing any settings on the universal router, we can start making the round tenons. Once again, we'll begin with top 1 and top 3. The first step is to draw a line 25 millimeters deep on both sides of each leg, and then mark the center point on each line. These two center points will serve as reference points when we cut the round tenons. First, insert the guiding pin into the center of the template. Then, adjust the laser to align with the center point we just marked, both the top center point and the side center point. Gently move forward the router bit until it touches the end grain of the workpiece. Then set the tenon depth to 25 millimeters, and we can start cutting the tenons on top 1 and top 3. Now it's time to switch to the second machine setting. We'll keep the work surface tilted up by 10 degrees, but this time we'll rotate the workstation 10 degrees to the left. By flipping all 4 legs 180 degrees from top to bottom, we can use this setting to make bottom 1, bottom 3, top 2, and top 4. Again, let the router bit gently touch the upper left corner of the workpiece and set the depth gauge to 0. With this setup, we can cut the second compound angle, 10 degrees from top to the bottom and another 10 degrees from left to right. We've already cut top 2 and top 4. Now, just like the previous step, we only need to flip the leg 180 degrees to make bottom 3 and bottom 1. Next, we'll use the same setting and the same method we just demonstrated. Start by drawing two lines, each 25 millimeters deep, and mark the center point on both lines. Then, adjust the machine so that the laser aligns with the top center point and the center point on the side. Gently move the router bit and touches the end grain of the workpiece, and set the depth gauge to 25 millimeters. Then, use the guiding pin to follow the template and shape the round tenon at the top of the leg. Next, we'll drill 4 holes, each 24 millimeters in diameter. These holes will serve as the mortise for the round tenons. Next, let's do a quick test fit with all 4 legs, just to make sure those compound angles match up perfectly. Now, we're going to make the 2 side support. First, draw a center line. Align the center line on the side support with the one we previously draw for the mortise, and clamp the side support to both legs. Mark the 2 angle lines, and now we're ready to cut. Right now, our machine settings remain the same, except we're going to bring the work surface back to level, while keeping the router stationed rotate 10 degrees to the left. Next, secure the piece in place and let the router bit gently touch the upper left corner. Set the depth gauge to 0, and we can make a 10 degrees surface cut here. After the surface is cut, insert the pin into the reference hole. Use the laser to align the center of the tenon line. Next, move the router bit so that it aligns with the tenon line, and set the depth gauge to 0. Position the guiding pin on the outside edge of the oval-shaped template, and we can start cutting. Flip the work surface 180 degrees to cut the other side. Repeat the same process to make another 10 degree surface, and then move on to cut the tenon using the same method we just demonstrated. Here are the 2 side supports we made. Each of them has 2 10 degrees oval-shaped tenons that fits perfectly into the mortise on the 2 legs. Now we're going to make 2 mortise holes on these 2 side support pieces. First, rotate the oval-shaped template 90 degrees to make it a vertical oval shape. Once the template is secured, place the guiding pin into the center hole of the slot. Then, use the laser to align with the center line of the support piece. Next, let your router bit gently touches the surface of the workpiece. Since the side support is 34 millimeters thick, and we're making a through oval-shaped tenon and mortise, we'll set the depth gauge to 35 millimeters. We'll also add a sacrificial piece behind the side support to prevent tear out. Now, move the guiding pin out of the central hole and insert it into the slot. Use the slot and guiding pin as a reference to cut the mortise hole in the center of the side support. Now we've come to the final step, making the center support. First, we need to measure the distance between the two side supports. There are two measurements to take, the top distance and the bottom distance between the side supports. Here, the top distance is 47.1 centimeters and the bottom is 48.3 centimeters. Add them together and divide it by 2, and we get an average distance of 47.7 centimeters. Next, we need to draw two angle lines at both ends of the middle support. Earlier, we set the angles for the forelegs at 80 degrees, so we'll draw an 80 degrees line on each end of the middle support. Make sure your router station is rotated 10 degrees to the left. Secure it in place, and just like before, let the router bit gently touch the upper left corner of the workpiece. Make sure the depth gauge is set to 0, and then we can start cutting. After the surface is cut, insert the pin into the reference hole. Use the laser to align the center of the tenon line. Next, move the router bit so that it aligns with the tenon line, and set the depth gauge to 0. Pull the guiding pin out from the center of the template and start tracing along the oval shape to form the oval-shaped tenon on the wood piece. Flip the workpiece 180 degrees and repeat the same steps. Now we can start assembling the whole chair. As you can see, the tenons and mortise fit together perfectly, tight enough to ensure the chair is sturdy.
Okay.
Of course, we'll check for squareness once more during assembly. This corner measures 72.3 centimeters and the opposite corner also 72.3. Perfectly square. If you enjoyed the build, don't forget to like the video, subscribe to the channel, and share it. I'll see you in the next project.